So, of course, as always, I'd like to start by saying thank you, everyone, for joining. My name is Cody Armstrong, and today we're talking about fixture design using Onshape. So, how to create any type of fixture using Onshape. And what I'd like to do here is really just focus on some common tips and techniques that I've seen other users use to develop fixtures inside of Onshape. Now, as I always say with these webinars, we really encourage you to ask any questions that you'd like. There's a questions dialog in the GoToWebinar control panel. Feel free to ask any question, and I'll do my best to stop and address the questions from time to time. So let's dig right into things. Now, the agenda today is real short. We're going to have a short webinar for you today. The big thing I want to do is discuss common fixture modeling techniques, not necessarily specific to Onshape, but just techniques that a lot of users have adopted in any CAD system for modeling fixtures, and then get into the specifics of those techniques for fixture design in Onshape. So we're going to discuss the commands that I think are more relevant to fixture design when you're doing it inside of Onshape. And of course, as always, I want to walk you through a simple example of building a fixture as well. So let's get into it. Now, before I get into the topic of the day, there are always a few questions I like to ask of the audience. So if you bear with me for just a moment, I'm curious, of the users listening today, how many are interested in Onshape for professional use? If you're using Onshape, maybe for your company or for personal professional project, let us know. If you're using Onshape for a hobby or for a 3D printer or something along those lines, also let us know. I like to get a feel for the audience and how many of those have come from that professional background. So I'll give you just a moment. If you would answer that poll, I'll close it out in just a second. And it actually looks like we're pretty close, even split. So 54% yes, using it for professional use, and 46% no, using it as a hobbyist. So that's great. That's a good amount, a good balance between the two different types of users that we often see. So let's get into it. Now, again, as I mentioned today, we're going to start off just by discussing common fixture modeling techniques, things that aren't necessarily specific to Onshape, and then we're going to get into how do we do this in Onshape. The first thing, what kind of fixtures? And really, I'm talking about any kind of fixtures. I use a generic machining fixture, but we could be talking about welding jigs, quality control fixtures, fixtures for a coordinate measuring machine or something to that effect. We have a screenshot there of a punch machine designed in Onshape, and it's a great example. But basically, think of any type of work holding or support device where you're modeling around your finished part in order to fix it to something or be able to attach it to a fourth axis or a vise or some kind of a table. There's all kinds of different examples where you might need to develop a fixture around other parts, and that's a big part of what we're talking about here today, is building in that top-down approach that allows you to easily model around other geometry you may have been imported. Maybe you got it from the engineering department. Maybe you've been emailed a file and you need to work around and manufacture that part. So that's what we're going to talk about here today. Just realize that a lot of the tips I'm going to show you aren't necessarily specific to machine fixtures or weld fixtures. A lot of these techniques are applicable in any of these scenarios. And I think that's what I tried to do, is boil it down to where the techniques I'm showing aren't specific to one industry. If you're building any kind of fixtures, chances are you're going to use the tools that I'm going to show you here today. So those are the kind of fixtures I had in mind, at least when planning, but just realize that, we've had users develop pegboard fixtures and for wire routes and all kinds of crazy things in Onshape. These are just some of the more common ones. So let's get into it. Now, what does this process typically look like? And this is not specific to Onshape. The process is really the same regardless of what CAD application you're using. Oftentimes, you're given a file. Whether that file is coming from the engineering department or from another company and you're doing the design or the manufacturing work for it, oftentimes it involves importing geometry. And of course, that means importing, STEP, IGES, Parasolid, Solidworks, whatever the format may be. But then equally as important is the ability to model around that imported geometry, what's often referred to as top-down design. Now, if you're not familiar with the concept of top-down design, it just simply means you're building parts with relationship to each other, building parts in the same space that allows you to easily reflect design intent. And I'll show you a quick example of this, but in Onshape, that amounts to a multi-part part studio where we can build multiple parts in a single context. So modeling parts with relationships to imported geometry. Now I say imported, but again, if you're getting it from your own engineering department or you model it yourself, may not be a must. But I think for a lot of users, they're getting these files, via email or something to that effect. So modeling parts with relationships to imported geometry, and of course testing the motion. Especially important in jig scenarios where the part moves and the tool doesn't. Those things, the motion becomes particularly important. But even in scenarios where the tool is moving and the part isn't, you want to make sure that you have the appropriate clearances and so on. So again, importing geometry, modeling parts with relationships to that geometry, and then testing the movement and the assemblies. Now, one last thing that I want to mention, it's particularly important if you do generate bills of materials, for example, of your fixtures, is assembling it as well. And I'm going to get into that, but there's really two reasons to create an assembly. You have, the motion. You want to be able to test the motion out, or I want to be able to insert all the nuts and bolts and make sure that my bill of materials has accurate quantities and all those types of things. So that's the idea, and that's kind of the process, regardless of what CAD application you're using. That's the most common process that we've seen. Now, how does this apply to Onshape? What kind of commands do I use in Onshape to accomplish this? And there are really a few that I want to stress today. I think they're going to be particularly important if you're designing fixtures. One of the first and most important is what we refer to as the derived feature. And the reason this is so important is oftentimes, let's say that I'm using a machining example here today. Let's say that I have my mill table or my vise or my fourth axis or some kind of table that I mount to the bed of the machine. And I'm always using these same parts over and over again. Very common in a manufacturing scenario. I need to design my fixtures around things that I've already got. I'm machining soft jaws, for example, for a vise, or I'm making some kind of fixture to bolt my part to a fourth axis. I need to be able to insert the fourth axis or the table or the vise into a part studio and model around it. And to do that, we need the derived feature. So I'm going to get into the derived feature in quite a bit of detail. Also, multi-part part studios. And the reason multi-part part studios are important is oftentimes you want to design your fixture around the part that you're making. And that means building multiple parts in the same environment. Often, again, referred to as top-down design. So if you heard of that term, that's what we're referring to. And all we're doing is we're importing this part that we've got to make, and then I'm building all these parts, maybe just a single part or multiple, around that part that I'm going to make, and then going out and making my fixtures. Now, a very important part of this, and this is actually, I've already gotten a few questions on it, is, how do I export to a coordinate system? Or how do I position a part inside of a part studio? How do I make sure it's oriented the right way? And the answer to that is transform with mate connectors. It's probably one of the biggest tips that I can give you here today, especially if you're doing a lot of multi-part part studios. I'm going to show you examples of all of these, so just bear with me. It's also very important if you export your geometry to some other application. The most common example I can give is, I export as a Parasolid or a step file, and I bring it into Mastercam or SolidCam or my CAM application of choice. And the question I often get is, well, how do I import it in the way that it was, that I want, and not relative to some origin that was arbitrary? I'm going to show you that in a second. Again, transform with mate connectors. But another big part is, of course, export. And so I'm going to show you all of these things here today and really try and sum up a workflow from start to finish for building a simple fixture. Okay, so I see a few questions. Suppose I want to start designing a fixture that deals with the product. What if the product is still evolving? In other words, I want to design the fixture and the product concurrently. There's no issue with that. If you're doing the product design and the fixture design all in the same document, it will update dynamically. And one of the biggest advantages to the modeling techniques I'm getting ready to show you, if I build multiple parts together and then I decide to change that original part that I'm making, the fixtures would update, assuming I've designed it with the correct design intent. So not only do we have the ability to do that, but we have the ability to make it really intelligent. I'm going to show you what I mean in just a second. But yes, you can design the fixture and the product concurrently, and they will update. Would assembly also be needed for drawings to show complete? And I will say that you can insert a single whole part studio into a drawing. I think the primary reason for creating an assembly is A, to test the motion, to make sure that nothing's colliding if you have motion in your fixtures, and then also to get the correct instance counts and all the hardware in so that you get an accurate bill of materials. If you're using your CAD model to generate a bill of materials for your fixture, the assembly is a must. And of course, motion. And those are the two primary reasons. You can take a multi-part part studio and drop it into a drawing. So, there are scenarios where you may not need to create an assembly. All right, so let's get into it. Now, these are the techniques that I wanted to show you. Derived feature, multi-part, part studios, transform with mate connectors, and of course, export. So let's get into it. Now, I'm going to start from scratch. And the idea today is really kind of to walk you through how I might do this, assuming I was emailed a file and I need to now, work that file into my fixture design. One of the first things I want to mention before I get into importing geometry is that oftentimes in these scenarios, you might have some kind of a library document. The example I have here is this is a fourth axis and a machine, a milling machine table, milling machine bed, right? And this is a standard part. These parts I use in dozens. Every fixture I design for this machine has these parts in it. And I need to bring my geometry into this and then make the attaching piece, right? You can see I have a fourth axis with kind of this dovetail feature to attach it to it. And I need to take these standard library parts, and yours could be a vise, yours could be, clamps, whatever the scenario may be that you use often. I put them all in one document. And it's just one approach, but it's an organized one. I can put everything in a single document that I use typically. And then when I get a new job in, I get a new project in, I import that geometry, I derive in these parts, and then do my modeling. So let's get into it. Now, what I want to do here, one last thing before I move on past this library part. I'm going to insert these parts into a separate document, right? The document that I'm importing. In order to do that, you must create a version. So just keep in mind, if you're going to use this workflow that I'm showing you here today, make sure that your standard library of parts has a version established. That way, when you go to insert it, you can insert from a linked document. Okay? So that's an important tip in your library parts. And I would just construct a document consisting of all the standard things you work with. My standard vise, my standard clamps, my standard compound table if I'm doing those kinds of operations. Build all of that into a single document, and then you can reference it anywhere you want. Question: How Onshape to handle mesh geometry coming from 3D scanner? Onshape can import OBJ and STL files. So those are the two formats that I would recommend. Oftentimes, if you're coming from a 3D scanner, you'd have to it generates a point cloud, which you then need to convert to an OBJ or STL. There are other applications out there that will do that, but once you have an OBJ or an STL, you can import that and reference it inside of Onshape. All right, so as I mentioned before, I want to start from scratch. I've already got my library of parts, just the machine components. But what I need to do is I have a new job. I have a new fixture I need to design, and I have someone has emailed me a Solidworks part file, and I want to design my fixture around that. So let's create a new document. Okay, we'll call it Fixture Webinar. And what we're going to do first is import our Solidworks part into this document. And so maybe you were emailed a part and could be Parasolid, Step, IGES. There's a long list of supported formats, but importing is all the same. I click the plus icon, choose import, and browse to the file that I'd like to import. In this case, it's called the supercharger housing, and it's an SLD PRT. So that will import and translate the model so that I can work with it inside of Onshape. And the process is the same if you have a Parasolid, a Step, and IGES. The workflow, everything I'm getting ready to show you here is really the same. Now, once imported, it will then translate, and you can see that SLD PRT file inside of Onshape. Okay? And this is, of course, a key piece because now I have the geometry that I need to reference to design my fixture. Now, this is the part that I want to manufacture, but I need to attach this part to that fourth axis that I was showing you just a moment ago. And that means I need to design a part that attaches here to that dovetail clamp fixture that you saw on the fourth axis. And so there are a few steps that I need to do here. One of the first and most important to what we're talking about here today is the derived feature. The derived feature will allow me to insert those parts, the machine components I was showing you a second ago, into this part studio, so that I have the table, the vise, the fourth axis, whatever it may be. It's all there together. So let's do that. Now, a quick question. Can you assemble by common coordinate system? You can assemble by a mate connector, which is in Onshape very similar to a coordinate system. So yeah, and I will show you that in a second. But if a step file evolves, don't we need to re-import that file? What happens to all the existing information that already took place? That is true. If you're importing a step file and then the step file changes, you would need to re-import the step file. You can update it, but you'll need to go back and modify any broken references that may happen because of the imported step file. Now, if your design is entirely in Onshape, that's not an issue, right? Because both the part I'm making and my fixtures are in the same place. But if I'm getting several iterations of step files or IGES files or Solidworks parts, you are right. It will need to be updated. Now, what I need to do here is insert all of these parts into this part studio. And I want to be able to model around them, position them, and so on. So the key thing there, again, derived feature. So this is my first step. I'll click derived. Then I choose what it is that I want to insert. Now, in this case, there's nothing from the current document. I need to browse documents and browse to that machine components document. Right? I'll choose the entire part studio, which grabs all the parts at once and brings them in. Okay? Now, the problem that you'll have, inevitably, is it's not going to come in the right orientation. And this is a common problem. It's going to come in the orientation it was modeled. But this is easy to fix, and it's the next important tip that I have for you, and that is positioning using transform with mate connectors. And you can think of mate connectors as a coordinate system. And essentially, I'm bringing two coordinate systems together and defining my position with them. Now, I'm going to do a lot of hiding and showing here, so let's hide some of these other parts here. And I first want to insert a coordinate system where I want to attach my part to that fourth axis. And so a tip, select coordinate system. Mate connector. Again, you can think of it as a coordinate system. And as I move my mouse over the cursor, you're going to see all these points appear. Right? As I drag my cursor around, you're going to see all these points wake up, and I can select one just by left clicking. Right? So now I've selected and created a mate connector at the center of that face. And that point is how I want to attach to the center of my fixture. Right? So that's the first step, mate connector 1, okay. Then what we'll do is we'll bring back all the parts, and let's hide our case. And I want to create a mate connector where I want to attach that part. Right? So again, we'll go mate connector. I want to attach it right at the end of this boss. You'll see there's a little pin that helps locate this part onto the fourth axis. And if I select that, that's about where I want that point to be. However, I want it offset a little bit. This part needs to be spaced out a certain amount away from the fourth axis for me to design my part. So an easy way to accomplish that is to select move, right? And shift this out. I can shift this out, let's say 0.5. Okay? And all that's going to do is move that mate connector out a given distance, whatever I decide, and then I can attach and move these parts around. So my next step, now that we've defined, I want to move the case from here to here, I need to use a transform to get it into that position. Right? So real easy, I can select, let's bring back the case. I'll select transform. This is the entity I want to transform, the supercharger case. I want to transform by mate connectors. Now, you have a lot of transform options. I just think that transform by mate connectors in this scenario is the most applicable. If you need to move up, down, and in the X, Y, or Z, you can do that. But oftentimes, it's a combination of a whole bunch of movements. So mate connectors makes the most sense. So transform by mate connector. And then I grab the mate connectors I want to move. So I can say from this mate connector to this mate connector. And like the name implies, all it's going to do is rotate that part around until the two mate connectors line up. Now, just like a mate in an assembly, You've got options to, flip the orientation, flip the primary axis. So again, very similar to what you may be used to in that assembly modeling environment. So there is my positioned supercharger housing relative to my fourth axis. I hit the green check, and now I have my supercharger housing in place. Question: if I rotate the initial mate connector, it should rotate the part as well. Yes, it will. So if you go back and edit the mate connector and add a rotation to it, it will affect how it handles that transform. It will rotate in the transform as well. Another tip is, oftentimes I don't care to see the mate connectors. It's easy to hide them. So after I'm done positioning my part, I really don't need them at the moment, so I can just easily hide them by clicking the I in the feature list. Now I've got my supercharger housing positioned relative to where it should be on the fourth axis, but obviously I have this big gap, and that gap is the part that I need to make to attach the supercharger housing to that fourth axis. So now we get into top-down design. This is one part studio with 8 parts, all the fourth axis parts, the table, plus the part I'm actually machining. The reason I like this approach is now I can reference all the existing geometry. I don't have to sketch things from scratch or take a bunch of measurements. Yeah, good point. Don't forget, you can now transform the mate connector as well. Yes, as of the last update, there's now an option to transform the mate connectors as well. That is a big one if you're doing a lot of transform with mate connectors. That was added as of just a few weeks ago. So very good point. Okay, so now I've got this thing in position. I need to start modeling the piece that's going to join the fourth axis to this supercharger housing. So let's hide a few pieces that I don't need at the moment. As I mentioned before, I'm going to do a lot of hiding and showing just to make things easy for me. And what I want to do is start grabbing edges and converting them. So I'm going to start at the bottom of this pocket. That's kind of how this part locates on the fourth axis. And then I'm just going to start selecting geometry and converting it. You can grab the face, the edge. It's entirely up to you. But I'm just going to take the things that I want. I'm not going to grab the numbers or try and reverse engineer it. The neat thing about building everything together like this is I can just say, okay, convert the edges of the Solidworks part into sketch geometry for my fixture. I don't have to figure out what those values should be. So once you've gone through and defined, okay, these are all the edges or faces or whatever it is that you want to convert, you can just click the Use command in the toolbar. Okay, that will convert that to sketch geometry, and now I can extrude. All right, so we'll click Extrude. An important step when you're building in a multi-part studio like this, I just created a new extrude feature. It assumes that I want to join this extrude with the housing, but that's not really the case. This is a separate part. So to do that, make sure to click New in the extrude, revolve, sweep, whatever the command is. Make sure to click New, and that will actually go through and create a separate part in your part studio. The reason that's so big is, of course, we need multiple parts in that top-down environment, right? So let's create new, green check, and now I have a new part in my part studio. All right, scroll down here. Just for clarity's sake, let's edit the appearance of this and make it a different color. There we go. All right, so now I've got this new part studio, part 9 in my part studio. Question, is there a way to select all those edges at once? You can click the face. If you prefer to click the face, you can do that as well. Now, I've got my first feature. This is going to be kind of the boss that this fixture locates on. But I still need to bolt this fixture to the part. I'm going to use these locating holes on the supercharger housing. So I'm going to create another feature. Let's create a new sketch here. And again, I'm just going to grab the edges. You can grab the face. It's entirely up to you how you choose to do it. And then just convert. Again, I don't need to take measurements or figure out values. I'm referencing the model that I was sent. Right? Click Use. That will convert it. I can even grab these holes and just convert them as well. Right? By the way, you can also window select. That's another fast way of selecting a lot of geometry at once. Now, if in this case I want to take this and extrude it. So I click extrude. And what I want here is to add this extrusion to the previous feature. Remember, this is all going to be one fixture that I'm designing, so I click add. And I say, okay, I want to merge this with the previous feature. All right, now those two become one part. And let's set our depth here. Now, I actually don't know the depth off the top of my head. Remember, I have a 1/2 inch offset, but I still don't know exactly the distance between faces. The beauty of doing it this way is I don't need to know the exact value, right? I can just bring those parts back. Let's show them and say, okay, let's extrude up to a face, right? And I can actually say I want to extrude up to a face in the part, in that part studio. Green check, and there is my face, okay? Now, in this case, make sure that it doesn't merge with what you don't want it to. And that's an important thing to keep in mind. I want to make sure that it's not inadvertently merging with other things. Okay. Now I've got this second extrude. It's extruded up to the face of my 4th axis fixture. Right? There's still an important step, though. You need to be able to add that dovetail feature that mounts it into that 4th axis. So not only can we reference the 4th axis for a face, for extruding up to a face, but now I can also say, okay, well, let's create a new sketch on the end face here, and let's grab the edges of the 4th axis and use them, right? Okay. And again, questions asked, can you select tangent edges once? You will get that behavior if you select the face. So I can grab all those edges, and we'll grab the edge of our fixture here. And now I've got a closed loop. This dovetail shape that I have can be extruded. Okay? So there's my sketch, and we can go straight to the extrude command and extrude it. Now, a few things, just like before, make sure to choose add and add this feature to our fixture. This is a part of our fixture. Okay? Now, in this case, I want to extrude up to the opposite end of the fixture. So I'm going to say up to face, click the face, and we'll extrude that dovetail cut all the way up to the other end of this part. Green check, okay. And there is that dovetail cut for our part. So again, I'm not taking measurements. I'm not figuring out what these values are, what the radiuses are. I'm not doing any of those things. I'm simply grabbing the edges of geometry I know is right and converting it. And that's the beauty of this approach, is you're not doing a lot of back and forth taking measurements. Right? Questions? Can I offset from a sketch plane, adding a gap on the back side of the pocket? Absolutely. There's two ways you could do that. You could, of course, insert an offset plane and sketch on that. That's one way. But you can also do what we call a two-direction extrude. It's very similar to the offset from option in Solidworks, if you're familiar with Solidworks. But essentially, you're going two directions, and the two directions are the same way. So two approaches, I think most commonly users would insert a plane offset. Can I select all tangent edges once? If you grab the face, it will do that, yes. If I try to import a subassembly file, DWG, and manage to import it, but when I use the try to subassembly reference, it would hire some, it did not work. Would you be able to go through a simple example of how this perhaps It's important to keep in mind, if you're importing a DWG and DXF, those are 2D CAD files. We're not referring to 2D CAD. You could then take your DXF or DWG and extrude, revolve, sweep, or loft it and create a 3D model. But you're not going to be able to take that and reference it as a sub-assembly. So forgive me if I'm misunderstanding there. What about the needed tolerances? Well, remember, in this case, there is no needed tolerances. And this is actually a clamp that adjusts up and down. Right? So the clamp arms pull up and down based on the design. But it would be very easy for me to, rather than convert, to do an offset. And do an offset of a few thousandths if I needed some clearance. So it's just as easy to do an offset as it would be to use or convert. But in this case, that's actually not needed because these clamp arms move up and down. Next question, I think very similar to the last one. What if I wanted an offset between the two dovetails? I would use offset and not the convert or use command. So a moment ago, I just clicked the edges and hit use. you would click the edges and hit offset, and then define however much offset you want between them. This will not fit together. It is no clearance. Both parts have the same measurement in and out. That is not true. These will fit because these arms move up and down, right? So just keep in mind that these two clamp arms are what are actually attaching our dovetail, not this edge, right? So these two clamp arms move up and down, and that's what gives us our clamping behavior. But again, if you need an offset, it's very simple. Just do an offset rather than a use. Okay. All right, so what I want to do next, of course, if you look at our fixture, let's hide what we've done so far. Let's hide part 9. There's a pin that it locates on, and I need to machine that pin into my fixture. I need to cut that pin into my fixture. And there's a few ways to do this. You could do a simple Boolean. Yeah, I could do a Boolean subtract. The problem I have with a Boolean subtract is it's going to leave me with a radius at the bottom of my pocket. And I don't really want a radius at the bottom of my pocket. I just want a simple hole cut into it. So what we're going to do, let's go ahead and bring back part 9. We're going to start a sketch on the front face of this fixture, right? Then we're going to hide it. Okay. Then what I'm going to do is I'm going to grab the cylindrical edge and again use, and this is another example if you want a small offset. Maybe in this scenario I would need a small gap. I would just do offset of that circle and say, okay, it should be, let's say, 5 thousandths, or maybe let's make it 10 thousandths of an inch. So there's a small offset from the circle. I didn't convert it. I offset it so that I have that slip fit, so to speak. Now I want to take this circle that's actually sitting on our fixture and cut it. All right, so we'll go to Extrude, Remove. All right, we'll bring back part 9, which is our fixture. And I'm just going to set a simple depth. You could do like an up to face, for example. In fact, let's do that. Let's hide our part 9. And I want to extrude this cut up to face and reference the end of that pin. Okay? So up to face, that face. So now I'm extruding that depth, just enough clearance for the pin. Then we get into merge scope. Remember I said before, and this is an important step when we talk about building these fixtures, especially in multi-part part studios like this, make sure that when you create a new feature, you're applying it to the correct part or parts. Could be multiple. In this case, I want to make sure the merge scope is our fixture, which is, if you remember, part 9. All right, so I click part 9, and that's really it. I hit the green check, and now I've cut a hole into that fixture plate. Now, a big tip, you'll see me doing a lot when you work in multi-part modeling like this, a lot of hide all parts, hide other parts, hide this part. All of these things can be found in that right-click menu. So I can right-click, hide the other parts, and now I have nothing but my designed fixture. Right? The designed fixture is referencing the dovetails. I have the nice cut with the offset to match that location pin. It's looking good. And again, I haven't added a single dimension to this thing besides the extrude depth. I'm referencing all the existing geometry that was there. So I've hidden all the other parts. For the purpose that I had, I really don't need them anymore. You could argue that I want to transform or something to that effect, but really my fixture is largely done. And now I can go in and treat it just like a single part by itself. Because all the other parts are hidden, I'm not worried about it, impacting them. So, maybe I need to come in here and add a few, relief cuts for the holes. Let's do a simple blind hole in these two corners to give us those relief cuts, like so. Make sure they're not going through. There we go. And so I can keep modeling and keep making changes to my design, even though, again, all the other parts are hidden. Just realize that you can model top down like I've done up to this point, or hide all the other parts and just treat it like a single part on its own. So here I added just a few relief cuts. I've got, my part. It looks good to go. I'm ready to start taking this into the machining operations, the next step. A few questions. Well, what are the chances that the dovetail is actually manufactured mathematically correct? Good luck matching them allowed to slide. It doesn't need to slide. These things locate right in. So the dovetails pulls it into the fourth axis fixture. The red and blue part do not have clearance. Again, same issue. You can easily add an offset between them if you need clearance. This particular example does not. What about breaking references? And this is a good question. You can easily export, and I shouldn't say export, but copy, and it will break the references to that. Just keep in mind when you're converting or anything like that, you're referencing existing edges. So it's going to grab using those special constraints. It's easy, though, to just select the constraint and delete it. I can even Windows select and delete, and that would break the references, so to speak. There isn't a break all references at once that I'm aware of, though. So forgive me. I'm quite certain of that. All right, so moving on. The last thing that I really wanted to get into here today is one of the most common questions. I've done all this work. I've designed all of these things. I've designed my fixture. I brought in my table, my fourth axis. I'm making sure everything looks good. Now, how do I test that this is actually going to work? Now, I will say for some users out there, this next step isn't necessary. As I mentioned before, if you need to create an assembly only if you want to test the motion, or if you want to insert all the nuts and bolts and get all the correct instances counts so that you can generate a bill of materials. I think those are the two primary reasons for creating an assembly. Remember, you can have as many parts in a single part studio as you'd like, but what you don't get here is dynamic motion. I can't grab this fourth axis and spin it around and see, is it going to hit the table? I can only do that at the assembly level. So if your design, your fixture is stationary, there's no movement, you're done. You can take this and export to whatever system you want, or whatever your next step is. But if you need to test the motion, the assembly is an important next step. So let's do that. Let's jump this over into the assembly, and I need to insert everything into it. Now, what's neat about this, if you model the entire part studio all in one spot like I did, I can insert all the parts at once. So if I go to insert, I just choose the supercharger housing. Because I've imported all those parts into that supercharger housing, everything comes in at once. And it comes in the same orientation that I had it in the part studio. Now, a big tip that I have is in the assembly, and this is not specific to fixtures, but in general, your first part, you generally just want to attach to the origin and hit the green check. If I move my mouse out here and left click, it's going to place it in some arbitrary position. So I'd recommend just clicking the green check to place all your parts. And you can see now I've inserted all the parts from that part studio in one shot. Now, when I bring it into the assembly, it's free floating, so to speak. So if I left click, drag, and move, you can see everything's free to move around. So I need to start constraining this to define its motion. And there are a few things that just simply don't move. The table, the fourth axis body here, they don't move. I can just right click and say fix. That's an easy way to fix them. Or I could group them. It accomplishes the same thing. So now the table can't move. The fourth axis body can't move. But I need the fourth axis to spin. That's an important part of testing the clearance and making sure that everything's going to work as I expect. So if we think about this, we want to group all of these parts together. They're all going to move in unison around this fourth axis. So I can select group, right? Then choose my instances, everything that I want to group together. So we can grab all of these parts, the fixture, the clamps, the face of the fourth axis, the actual spindle, all of them can be grabbed. You can even select them, of course, from the part list here as well. So in this case, let's grab a few of the parts here. Okay. And green check. Okay. And now I always like to test it just by grabbing it and dragging it. And you can see all those parts are now moving as one piece. Okay. So I don't need to mate all of them together. They were already in the right position. They all move together. So it's just as easy to group them. Right. And so now I've grouped all the fourth axis pieces, my fixture and my part to be machined. Now I can select revolute, and I want to revolute mate between the spindle here and my fourth axis body. Of course, that revolute mate gives me that rotational degree of freedom, and the ultimate test of the assembly is going to be right-click, animate that revolute mate, and spin it around. Right? And I can spin it around. I can see it does not collide with that table, although it does come pretty close. Right? So animating a mate is an easy way to see how much motion you have, and also, are you going to hit? Are you going to collide with anything? Okay. So if you need to test the motion, if you need to animate the assembly, make sure to, or you need to animate your design, make sure to create an assembly. And I think that's the important last thing that I wanted to mention here. If you need motion, or if you want to get a correct bill of materials with all the instances and nuts and bolts and so on, make sure to create an assembly. Okay. Now, I've created an assembly. I've tested my motion out, right? Everything's good to go. I know my fixture is ready to go. Oftentimes, the last step is bringing this into my CAM application. And I already see a few questions regarding this. So the important thing to keep in mind is, oftentimes the questions come up, how do I bring this into my CAM software? And the simple answer is to export. However, keep in mind when you export, it's going to export relative to the origin that it was modeled in. And that may not necessarily reflect where you want the origin of the CAM model to be, or maybe where I want to establish my work offset in the CAM model. So there's one last thing that I want to point out, and it's just a commonly asked question, especially in those in like the machining world where coordinate systems are a really big deal. Do we have the ability to export to a specific coordinate system? And the short answer is no, but there's an easy solution to this, and it's using the same tool that I've already briefly mentioned. So let's do this. Let's hide the parts. And here's our origin. Actually, real quickly, before we do that, here is the mate connector on the end of the part, right? And that's actually where I want my origin to be. But right now, the origin's over here on the right, right? So what I need to do is shift everything over to that position. And it's just as easy to do by, again, using that transform with mate connectors. Now, another big tip is you can insert a mate connector relative to the origin. Okay, so I can say, okay, the owner part is the case, and I want to reference this, let's say, realign to the right plane. Okay, and that will give me that normal direction, an important step. Make sure that you can see the blue is the z-axis of the coordinate systems. You want to make sure that's pointed in the same way. Now, just like a mate, I can flip the direction if it's going the wrong way, green check, and now all I need to do is do a transform between these two mate connectors. Then when I export, the origin will be exactly where I want it to when it comes in to that CAM application that I may be using, right? So let's do a show all parts. Let's do a transform. I want to transform everything, right? So I'm going to shift everything over all at once. An easy way to do this, by the way, is just shift select or Windows select all the parts and say transform by mate connectors. And I want to go from this mate connector to this mate connector. Okay? That grabs all the parts, shifts them over to the corresponding mate connector, now on the origin, now in the place that I expect. Hit the green check, and now I can easily export this, and it will come in this orientation in the CAM model. Now, if you've modeled it in Onshape, chances are this isn't going to be necessary. It's going to come in the same orientation you modeled it, and if you're designing it that way, you're thinking ahead. But if you're getting the model from some vendor or some other person, that this is going to be an important step. Exporting relative to a certain position. So that final step, transform with mate connectors. Now it's real easy for me to right-click, export, choose any format that works. Parasolid, ACES, Step, IGES, Solidworks, whatever format that you want, and okay, and it's going to download all the parts at once. And assuming your CAM software supports all those things, you can bring all of those in, even do things like avoids and contains and all the things that you can do in CAM applications. But again, the neat thing here is you can define all of those things, test the motion out, build your fixture, do all of that inside of Onshape and then just simply export to a CAM application. Now, if you haven't checked out the Onshape App Store, there's a lot of CAM applications in there. So if you're looking for a CAM application, definitely check out the Onshape App Store. But really, that's the workflow. You're bringing in a part. I would recommend, and this is just a recommended approach, put all your library parts in a single document, a vise, table, fourth axis, clamps, whatever it is that you're designing, and then just insert those parts into whatever new projects that you get. So if I get a new project tomorrow, I'm going to walk through the same workflow, import it, bring in all my, my vise, my table, whatever it may be, model the necessary pieces I need to model, and test the motion out if I need to. So that's really the workflow kind of from start to finish. Import the part, derive the part in, and then model it around it. The key things, and probably one of the most important tips that I have for you today when you're doing this top-down design is the transform with mate connectors. That is very similar to mates in Onshape assemblies, and it allows you to position parts in the part studio. So an important one, and I think for a lot of users, that's where it's easy to get hung up. So that's really what I had planned. I'm going to stick around and answer any questions. In fact, I see a few here, so let's get to them. Question, will the CAM see the updates? It depends on the CAM, but most often, no. It's not a dynamic updating environment between them. I won't say that's the case for all of them, though. If something were to just collide, does anything flag this? If you do a section view in Onshape and it's colliding, it's going to show in bright red. So just keep in mind, if you're looking for a way to see if parts are colliding, one of the easiest ways is to do a section view and grab it, and you'll see that it's in bright red. There's no tool to stop it or to detect collisions or anything like that, but it's fairly easy to see, this part is overlapping with this one using a section view. Question, is there a 3D sketcher function available? No, we do not have a 3D sketch capability as of yet. We do have a feature that will allow you to generate a 3D spline, but it's not a true 3D sketch line capability, not true 3D sketch functionality. I will say that is a high priority for us, though, so definitely keep an eye out, hopefully very soon. All right, so that is what I had planned. I have one real quick last question for you, so if you would bear with me for just a second. Are you interested in a private demonstration or discussion with one of our account managers? If you're interested in discussing maybe how Onshape can fit what you're doing day in, day out, how it can be used in your company, definitely let us know. We can have one of our account managers reach out to you and answer any questions that you may have. So again, I'm going to stick around and answer any questions. I'm going to go ahead and close this poll out. We'll jump back to our slides real quickly here. Again, I'm going to stick around and answer any questions. So if you have them, please feel free to type them into the GoToWebinar control panel. But that's it, everyone. Thank you and have a good day.